Very good. So we'll be starting. Now, what is the chemical reaction, Arthur? What is the chemical reaction, Arthur?
They are the chemical changes.
What is the chemical change?
Chemical change like any chemicals that react with each other and then we get a particular change,
Mm-hmm. Good.
or a reaction change, or any chemical that changes when it's in, like changes its temperature. That's a reaction.
Mm-hmm. That's a reaction. Right. You said chemicals, they react together to give you some different parts. All of that. Fine. Good. But then my question would be, what is a chemical and then what is a reaction? You know, you told me a chemical reacts, many chemicals react. That's fine. Correct. But then to understand chemical reaction, I think we will have to understand what is a chemical and what do we mean by reaction. What is happening in that reaction? Getting? Getting my question? Yeah. Just think for a second and then let me know the answer. Yes. Beta, unmute yourself.
Yeah.
Yeah.
Chemicals are the substances, which substances like a substances, and
Mm-hmm.
reactions are something like those substances when substances are like
Mm-hmm.
uh, not getting the point.
Okay. No. See. Well done. See. A chemical change is any change. A chemical change is any change when a change in the chemical composition happens. Yes. Any change in which a chemical composition is changing, that change would be referred to as a chemical change. Clear? Now, the reaction is this. What do we mean by a reaction? Any reaction, when a reaction is taking place, what does it mean? It means that the change in the chemical composition is also taking place. Getting it?
Okay.
Okay. And chemical composition, we must have studied this in class 9, first chapter and the second chapter. Chemical composition of matter is there. And what do we mean by chemical composition of matter? It means that how is that matter composed of? Yes. What is it composed of? The atoms, the ions, the molecules, the elements, the compounds, all of that are different constituting units. Yes. Now, can you tell me what is what do we mean by a change in the composition, the chemical composition of an atom? What happens if we are saying the chemical composition is changing?
They will be gaining and losing of electrons in it.
Very good. Very wonderful. So if we are to assume that matter is made up of atoms, yes, atom is the fundamental unit of matter.
Yeah.
Yes, atom is the fundamental unit of matter. So when we are saying chemicals are reacting, basically the atoms would be reacting. Yes or no?
Yes, ma'am.
Right? You getting it?
Yeah, ma'am.
And so the primary level at which reaction happens is the atom. Can we say it like this? The primary level at which the reaction is taking place is the atom. At which the chemical configuration is there is the atom.
Yeah.
Yes. And what is the structure of an atom? What is the configuration of an atom? Very quickly. It has three subatomic particles.
Proton, electron, and neutron.
Very good. Electrons, protons, and neutrons. Where are the protons and the neutrons situated in an atom?
Neutron is the dot, the very least one,
Mm-hmm.
and the electron is the first circle. The proton
Uh-huh.
is the second.
Okay. See, but you know. See. Electrons, can you tell me any charges here? Electrons are the positively charged or negatively charged?
They are positive. No,
Okay,
sorry,
so
they're negative. They're negative.
yeah,
They're
no,
negative. They're
very good.
negative.
Electrons
Protons
are
are positive.
negatively charged. Protons are
Are
positively charged,
positive. Neut-
and
they are neutral.
neutrons are neutral. Very good. The neutrons and the protons are together found in the nucleus of the atom. In the
Nucleus.
nucleus
Yeah.
of the atom. And nucleus, where is it? It is at the center of the atom. It is at the center of the atom.
Yeah.
Now, electrons are left. Electrons are found on the shells which keep on revolving around the nucleus of the atom. Yes,
Okay.
electrons are found on the electronic shells. Let's quickly draw this. Let's say this is the nucleus. It has the proton and the neutron. Then we have the shells around the nucleus. Okay, like this. And on these shells, we have the electrons. Okay? You know this much, right? This is the structure of an atom. Now, we are clearly seeing that there is a certain kind of chemical composition of the atom. Now, the number of the electrons and the protons and the neutrons, that would be playing a very important role, yes.
Yeah, ma'am.
And how do we get to determine that? How many electrons, protons, and neutrons are in an atom? Any idea?
They have different values, right? For
Yeah, they have
each.
different values. Yes. No worries. Are you able to recall any terms that you have studied regarding this?
Mm,
No? Okay. I will discuss that later after you have attempted the test, so then it's easy for me to understand. Okay. Yeah. Now, coming here. You told me a very valid and a very good point that atoms either lose electrons or they gain electrons. Yes?
yeah.
Atoms. Let's assume it had 7 electrons. Okay. Let's assume. And let's assume due to the properties of having these 7 electrons, it will gain 1 electron. Yes. So earlier the chemical composition had 7 electrons. Now the chemical configuration has 8 electrons. Clearly there
Yeah.
is a change in the chemical composition. Yes.
Yes, ma'am.
Therefore, will it be a chemical reaction? Yes, it will be a chemical reaction. And how will this atom gain 1 electron? It will gain by engaging itself in a chemical reaction. Is that correct?
Yeah.
Yeah, very good. Can you give me any example of a chemical reaction, Arpa?
When a chemical reaction,
In any example that happens in our
when
day-to-day life?
like I know one, when zinc reacts with sodium chloride, we get zinc chloride. No, uh, yeah, we get zinc chloride and sodium as a byproduct.
Okay. When you said when zinc reacts with
Sodium
sodium
chloride,
chloride,
we get zinc chloride and
uh-huh,
zinc
sodium.
chloride and sodium as a byproduct when they react. Sodium.
Yeah. What is the chemical formula for zinc chloride? Any idea, Bachchi?
Zinc chloride is Zn plus Cl2.
Plus
So ZnCl2, ZnCl2.
Cl. No worries. Good. See, this is if you represent it like this, it can be considered as a chemical reaction. But let me just tell you, this reaction will not take place. Okay, this reaction will not take place because zinc cannot displace sodium from sodium chloride.
Oh yeah,
Yeah, zinc is a less reactive metal. No worries, we will discuss this in detail. But any other example, very common example, day to day life.
yeah. This one.
Yeah,
Hydrogen plus oxygen give rise to water.
wonderful. That is a best example of chemical reaction. So whenever a chemical reaction happens or takes place, a chemical change is there involved, yes, and
Yeah.
the chemical composition from the of the initial reactants, it is changed to a new chemical configuration, and because there is some new configuration, there is new chemical composition that is considered as a new substance. Yes, Therefore,
Yes.
a new substance or a new product is formed in a chemical reaction. Is the
Yeah.
chemical reaction reversible or is it irreversible?
It depends, right?
It
It
depends.
might be, it might not.
It might be, it might not be. Okay.
Yeah.
Now, coming on to the next one. If I ask you, Bache, can you give me one point as to why atoms they lose or gain electrons? And let's see, let's assume I have 7 electrons in one atom. Okay, there's any atom which has 7 electrons. How will I get to know that how many electrons can it gain or how many electrons can it lose? No worries, just relax. Whatever you have in your mind, you can share. Yes, don't hesitate, huh? Whatever points you are having in your mind related to this, simply share that. Yes, Bache. No.
I don't know how.
Okay. Okay. Wait. What we will do is that we will have your test here. Okay, right now. After the test is over, we'll start discussing all the important. Yeah.
Yeah, sure, ma'am.
Just give me a second. I'll quickly open that test for you.
Okay, ma'am.
Yes. Ashwin, what we'll do is that I'll have the test here on the screen. Go
Yeah,
through the
ma'am.
instructions, and then after you are done reading the instructions, we'll start with the question. As soon as you're done with the question, you know the answer. You just tell me the answer for that question. Yeah.
Okay, ma'am.
Yes. Please go through the instructions.
Then, ma'am, I have read the
Okay.
instructions.
Should we
Yes.
start with the first question?
Yes, ma'am.
Please do that.
Ma'am, first one is option C.
Second one,
Second one is helium C.
third one, take your time. Huh? Yes, Victor. Yes, Arpa.
Yeah,
Unmute yourself. Nice. Yeah.
just a second. This.
Yes, Acha.
Yeah, ma'am. For the third one, the number of protons is 13. Number of electrons is also 13. The number of neutrons is 27 minus 13, which will be 14.
Atomic number.
Atomic mass, atomic number is 13. And atomic mass, which is denoted by A, is 27.
Okay. Question 4.
Yeah, just a second. Okay, for this one. For fourth one, phosphate,
Fourth one.
yeah, for
Okay.
fourth
Yeah.
one. Phosphate is having 3 as its valency.
What is the formula, Bache? The chemical formula for phosphate?
PO 3 4. I don't know how to like tell it completely. I just remember like that.
Uh, 4 has to be in the subscript.
The down
Yeah.
one.
Above we have 3.
3, yeah.
Can I call that as the valency?
Yeah, 3.
Sulfate.
Sulfate is 2. Valency is 2. SO 2 by 4. 2 will be the valency. And
Right.
nitrate will be 1.
Formula.
NO dash 3. Yeah.
Like this.
Yeah, this is correct.
This is correct.
Yeah, nitrate.
And not dash.
No, that the line, the sleeping line.
Minus.
Yeah, minus. Yeah,
What is the valency?
1.
Ferrous and ferric.
And then ferrous sulfate is 2.
Mm-hmm, mm-hmm. It's not ferrous sulfate. It's
Sorry,
just
ferrous ions.
mm,
Ferrous ions is 2. That's positive 2. Fe2.
which is symbol for ferrous.
Fe
Okay. Plus 2.
plus 2. Yeah, positive 2.
Ferric.
And ferric is Fe3. That's positive 3.
Sodium.
Sodium has valency 1.
Mm-hmm. Symbol.
Na. And calcium is Ca2, positive 2. Ca2.
Right.
Yeah, correct.
Question 5th. Yes, Arpa?
Oh yeah, ma'am, just a second, last one. Yeah, ma'am, I'm done for the question 5.
Please answer the question.
Calcium carbonate, CaCO3, CaCO3. Aluminium sulfate, Al2SO4, and calcium phosphate is Ca2PO4.
Yes.
Yeah, that's one.
Fine. Question 6, बच्चे. Should we move on to this? It is
Yeah,
molecular mass.
I'll do it now.
Yeah. Yes, Arpa?
Yes, ma'am, just a Yes, ma'am, I'm done for the sixth one. I'll say.
Mm-hmm.
Sodium is 2 uh, 23U. Aluminium is 27U. Calcium is 14U.
1414, right?
No, 40.
Okay.
40 and 40. And oxygen is 32. 32.
Seventh one.
Yeah, question 7. This one it's calcium, and it's this one configuration is 2882.
Valency.
Valency is 2.
16. Which element has the...
Sulfur.
Okay, what's the symbol for sulfur?
S.
Small, capital.
Capital.
Configuration.
Configuration is 286.
Valency.
C is 2.
2.
Yeah, valency is 2.
Fine. Third one.
Next is neon. It's Ne, and configuration is 28.
Valency.
Is 0.
9 बचे.
9. Yeah, fluorine.
Symbol.
F. Capital F.
Capital. Okay.
Yeah.
Yeah.
Configuration is 2 and 7,
Mm-hmm.
and valency is 1.
10.
Ma'am, for this calcium, the first one, it's 282. I said that 8 twice. Calcium, calcium, calcium. I'm sorry for this one. Yeah.
Fine.
And, the last one with 12, it is magnesium. Mg, capital M and small g. Configuration is 282.
2, 8. Valency.
Valency is 2.
Fine. Done. Anything else that you would want to add into any question?
No, ma'am.
Okay. Should I finalize it?
Yes, ma'am.
Yes. Let's quickly try to analyze it. First one, light. Done. Um, which of the following is a noble gas? What is a noble gas? Answer is correct, but what is a noble gas?
Total gas.
Yes.
Which are not there in the atmosphere.
No, but noble gas is any gas that is unreactive.
Oh,
Yeah. So helium is an example of a noble gas. We have other examples as argon, krypton, neon. All of that is inert gases or noble gas. Correct. Third question. Number of electrons 13, protons 13, neutrons 14, good atomic number 13, and atomic mass is 27. Before here. Fine. That's right.
Actually, that
Oh,
man is mass or that's
it's
the
mass.
name?
It's
It's
mass.
mass.
Yeah. What letter is used to represent the atomic number? What alphabet is used?
Atomic
Number.
like number A.
Atomic mass. Atomic
Yeah.
number is represented by a capital Z, and atomic
Oh,
mass is represented, which is mass number, is represented by a capital A. Okay,
mass is
clear?
number is Z, right?
Yeah, number is by Z. Fine.
Yes.
Fourth question: phosphate ions correct, sulfate correct, nitrate correct, ferrous ferric correct, sodium calcium correct, calcium carbonate correct, aluminium sulfate. Is the screen visible? No, there's some problem. Just a second. I'll open that again. Is it okay now?
Yes, ma'am, it's visible.
Yeah. So calcium carbonate correct, aluminium sulfate not. Uh, can you tell me how did you figure this formula, chemical formula for aluminium sulfate? What steps did you follow?
I remembered the formula, so that's all by
Okay,
applying
fine,
that.
no worries. Yeah. Can you tell me what steps do we follow to find the chemical formula, bache? Is there any method that we use to calculate?
Crisscross.
Yeah, we
Crisscross.
crisscross. Very good. What do we crisscross?
Aluminium and sulfate.
Yeah. But like between what do we do that crisscross? What do we have for aluminium? What do we have for sulfate?
For aluminium, we'll have
Do we
the number
crisscross the
you're asking.
valencies? Yeah. Do we have
Yeah,
the
the balance
valencies?
two.
Let's say
Aluminium.
aluminium is plus 3. Okay. Sulfate is
Okay.
minus 2. No worries, no worries, no worries. So aluminium, we are learning. That's fine. Alpha. Okay. We will crisscross. We will get Al2 SO SO4. How we will write that 3 there?
Al2 SO, that valency will be there.
Yeah. How?
SO3
And what
minus
about the 4 there?
4 will be there.
So I'll write it like this. See, like this.
No. The 3 will come up like here. Yeah.
That's wrong. What we'll do here is that see Al2 SO4 whole thrice. Yes, because this is 1 here. We are having this 3 for this all of it. Yes,
Yeah.
so that will be the case. No worries. So we call it as Al2 SO4 whole thrice. Okay. Yes, Viche? You getting it?
Yes.
Some confusion is there. What's that confusion?
Yeah, I completely forgot about the bracket. I
No
was.
worries. That's fine. That's fine. That's fine. You are learning. That's fine. Calcium phosphate. Again, wrong. See, you just now told me phosphate has a valency of 3. So if calcium has a valency of +2, phosphate is PO4 -3.
4 whole 3.
Yeah,
Yeah.
no worries. Coming on to the molecular mass, that is 23U, perfect, 27, 40U, 32U, very well. What do we mean by molecular mass? Alpha, any idea? Yes, Alpha.
Molecular mass. That the number of atoms, protons, and all together.
Is that molecular mass?
No.
Mm-hmm. Then what is atomic number? See, no worries. Atomic mass refers to the mass of an atom. Yes, the mass of an atom. And how do we measure the mass of an atom? Any idea?
Ma- Yes, ma'am. Can you repeat?
Yeah, how do we measure the mass of the atom? Any idea, bache?
Mass by adding electron and protons.
Good, good. Actually, what happens when we take the mass of an atom? We just take the masses of all the protons and the neutrons present in that atom. We neglect the mass of the electrons because the mass of the electrons is very, 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 very small in comparison with the mass of the one electron and one neutron. Okay, so that is it.
Okay.
But my question is, how do I like if I need to buy 1 kilogram of apple, okay, I will have a 1 kg mass there on the other side of the balance, and then I'll weigh that. Yes. How do I measure the mass of it? What is this U? What is this unit of U?
U is the molecular mass.
U is the molecular mass. Okay. And then what is if U is the molecular mass, then what is if how can U be the molecular mass? Is this the unit?
Yeah, it's a unit.
Is the unit. What does it stand for? Is there any full form for this U?
No, I don't know the full form.
See, U represents unified mass. U represents
Okay.
unified mass. Okay. And written. The molecular mass means what? The number of atoms are present. We will add the mass of all the atoms. That will give us the mass of the molecule. Yes.
Yeah.
Now it is a relative atomic mass and a relative molecular mass. Do you understand these terms? Relative.
Yes.
Yeah. And what do we have as the reference point to measure the mass of the atom? What do we have as the reference point, Viche? No. Are you able to recall something as 1/12 the mass of carbon 12 atom?
Carbon 12. Yeah.
Yeah. So that is the reference point. We will discuss this in detail. No worries. Okay. Coming on to the seventh question, write down the electronic configuration. Wonderfully done. I just want to ask you one question here. Can you tell me if calcium has a valency of 2, what charge will it gain overall? Will it be a positive charge or will it be a negative charge?
It'll be a negative.
Negative one. What will be the charge because on due to the valency of sulfur? Positive or negative? Yes,
It will be negative.
it will be negative. On neon, that's 0. So probably I think that will be without any charge. Yes.
Yeah.
Yeah.
No
For
charge.
fluorine,
Negative. Negative.
negative. Okay. And magnesium,
Magnesium will be positive.
positive. But the calcium will also be positive because it will be losing 2 electrons. Yes.
Oh,
So no worries. What we'll do is that we'll not have any extra class as such for the revision, but I will try to cover some of the concepts here in the first class of the first chapter. Yes. So that your concepts are clear and then you are moving on to the proper first chapter. Is it okay with you, Aspa?
yeah.
Otherwise, see,
Okay.
most of your concepts are very clear. We'll just revise some of them. Okay. Like some of the
So,
important compounds with the ionic charges on them. You know how
okay.
do we know get the formulas? You know that, okay? And
Yeah.
then we'll be revising atomic number and atomic mass. That's it.
Okay. So you think I need a bridge course?
No, you don't need a bridge course. I'll be starting it in the first chapter itself.
So when will be our next class?
That the team will tell you, the team will schedule it accordingly. Whenever our next
Okay.
class will be, we'll be starting with the, we have already started the first chapter. Okay. We'll
Yeah.
continue that, and then we'll have some of these concepts, and then we'll come to the balancing of the equation. Correct?
Okay.
Okay.
So it means I don't need any bridge course
No,
for
in my
now.
opinion, yeah, in my opinion, you do not, actually, you know the concepts. It's just that you are not able to recall some of them right here. That's it.
Yeah. The main
Yes.
definitions.
Definitions I'm not concerned with. I just want to know whether the, concept, I can see the conceptual clarity. Else, I will revise some of them. Okay.
Okay.
Tell me this honestly, do you think that you need a revision course?
No, I remember most of the thing, and you're
Yeah.
telling that you will revise something a little more
Mm.
from the
Yeah.
past.
I'll actually try to revise the atomic number, the atomic masses, and some of the important compounds with their charges. Yes, the ionic compounds and their charges, so that you are not confused in that. And one important thing that I would try to like recall, revise in the class is that how many atoms and how many molecules are there? How do we get to know that? Example in Al2SO43, how many atoms of aluminium, sulfur, and oxygen are there? So we'll just quickly revise it again. Okay? Because that will be
Okay,
very
ma'am.
useful in balancing of the equation.
Okay.
Okay? Any other query, Aisha? Sorry, Arfa.
No, ma'am. No
Okay.
query.
Okay. We don't have much time left. We have 3 minutes left, so I would want to stop it here. Inshallah, in the
Yes.
next class, we'll continue on the first chapter itself. Okay.
Yeah. Okay,
Tell
ma'am.
me any other change that you want to be made in the way the class conducted, or you are okay with it?
I'm okay with it, ma'am.
Okay. 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 We'll meet in the next class.
Yes, ma'am. Sure. Thank
Just
you.
revise some of it as much as possible, and then
Okay, ma'am.
obviously we will start in the next class.
Okay, ma'am.
Thank you. You will leave. Thank you.
Nice meeting, ma'am.
This class, am I audible? Safrina Ubaidullah Ali.
Yes, ma'am.
All right, please open the camera, all of you. Ubaidullah Ali. In the last class, I stopped at this point and we had to continue from here. We discussed the force on a single wire which is carrying current. What was the formula of it? Yes, unmute yourself, class, and answer. What did we discuss in the last class? A formula was there which we discussed. Force on a current carrying wire. A very short formula we discussed.
F is equal to I into L cross P.
Yes, very good, Ubaidullah. BIL sine theta, which we did, right? We stopped at that. Now, see, when you have two parallel wires, it's like two parallel wires are present. Now, what will happen when you are calculating the force on this wire? The magnetic field that will be exerted will be due to the first one. How is the force exerted? Force is exerted if you are calculating the force on this, then the magnetic field of this wire will be exerting the force on the first. Similarly, if I want to calculate the magnetic field on this wire, the force on this wire, so I'll take the magnetic field of this because its magnetic field only will be influencing it. Right, so that's why in two parallel wires, this is just a particular case that comes in the exam. Force between two long parallel current carrying wires, so two long conductors with a separation d, and both of them will have the equal length. In your syllabus, you don't have an equal length, so you don't have to do that. So let's say let's calculate the force on 2 due to 1. Okay. So here we'll have the magnetic field due to 1. Magnetic field of this wire will be influencing the second wire. Now, when we're talking about the first wire, these are infinitely long wires. What was the formula for infinitely long wire? Can anyone tell? Magnetic field due to infinitely long wire.
Mu naught 2 pi r.
Yes, very good. Mu naught I by 2 pi r. So this is mu naught I1 by 2 pi. Now, what's your point of calculation? This time we are calculating on the second wire. That's why we are going to take the separation between these two wires, which is D. So instead of taking a point as P, separation as R, that is not required here. So this is 2 pi D. Magnetic field of the first wire on the second. Okay, B1 means magnetic field of first wire on the second. Now, when you're calculating the force on the second wire due to the first one, F21, let's say. So this will be, we have studied BIL, and we had one more thing, sine theta. Now see, current will be of the second wire. Length is of course the same in both the wires. So you just consider the length as L. But magnetic field will be the first. Because why do you have the force? The force is because of the magnetic field of the other wire. If that other wire wasn't present, it wasn't exerting a force then. So B1, I2, L. And here if you can see, the length of the wire and magnetic field are perpendicular. So you have this case only when they are perpendicular. Otherwise, it will be different. And see, this is actually a derivation only. This is a kind of derivation which comes very less. Usually the questions, numericals come from this. Here you'll make it 90 degree. Theta will be 90 degree. Sine 90 degree is equal to 1. So force on the second wire due to the first. Look, B1 is mu naught I1 by 2 pi d into I2 into L. That's all I'll have. Now see, what is the force? Complete value of the force. Force on the second wire due to the first is mu naught I1, I2, L by 2 pi d. So that's it. This is the entire derivation. And I'll tell you more than the derivation, the numericals come from this. Now see, if I somehow shift this length here, if I take this F21 and I divide it by this length, means I bring this length here. So I'll be left with mu naught I1, I2 by 2 pi d only. This force per unit length is represented by a small f. So small f is like a standard formula. Many a times you will not have the length. It won't mention anything. So don't be confused about that. When nothing is mentioned, it directly means that this is talking about the force per unit length. So force per unit length on second wire due to first is mu naught I1, I2 by 2 pi d. If length is mentioned and it says only force, then you use this formula. Even if it says calculate the force and length is not mentioned, then assume that it is saying force per unit length. Many times for force per unit length, the questions aren't very clear. In the board exams, these kinds of questions have come. So if length is there and when force is asked, then only use the formula. Otherwise, this formula is sufficient. You will yourself realize this is not a tough thing to decide during the exam. And do the otherwise round, means let's calculate the force on the first wire due to second. See, will there be any change? B, instead of B1, I'll have B2. Instead of I2, I'll have I1. For B2, I'll have the current here, I2. Ultimately, when I'll multiply I1 into I2, it will be this only. So when you are calculating magnitude wise, your F12 will also come out to be the same, mu naught I1. It will be mu naught I2 by 2 pi d into I1 into L. Isn't it the same thing? It's exactly the same. But there's a difference of direction. One force is acting towards the right, other force is acting towards the left. Both the wires are acting on opposite sides. That's why we say F21 will be minus of F12. Now here the best part about the direction is that you don't have to apply any right hand thumb rule or anything. Just look at the directions of the current that are flowing through the wires. If the current are flowing in the same direction, like see, both of these, if it is in the same direction, whether upwards or downwards, means both of the current should be upwards or both of the current should be downwards, then the wires attract each other. And if it is opposite, here up, here down, here down, here up, anything like that, then they repel. So current, if the currents are moving in the same direction means either up or down, both are possible. So in the same, they will attract each other. And even if either is an opposite side, let's say this is moving down, this is moving up, or this is down, this is up, so opposite side, they'll repel each other. So this way you will have a very clear picture of the direction. Like let's say we have calculated the magnitude of the force, and I ask you what is the direction of the force on the second wire. So you can see, okay, both are getting attracted. These two wires are getting attracted. Obviously, this will move towards it and this will move towards it. If they are getting repelled, they'll move away. So, you know, I cap, J cap, you can write it in that manner. You can write right, left also, or away from first, like this also. Okay, so direction part is the best here. See, write it till here, then let's discuss the next. Okay, write down this. Have you written it till here, all of you?
Last.
Both of you had the chemistry class till now. It just ended right now.
Yeah. Yes, ma'am.
Okay. Just do one thing. Both of you take the screenshot of this page. Yes, completed.
Last.
Yes, done.
Yes, ma'am.
All right. So see, there is one question that comes. Define 1 ampere. Okay. 1 ampere here means, see, usually if you get the question, define 1 ampere, you have to define it through your current electricity. But it will specify define 1 ampere between using the force between two parallel wires. So how will you solve it? See, force per unit length. All right, the force per unit length that we have, this is mu naught I1 I2 divided by 2 pi d. Okay, class. Now see, if I make this current I1 equal to I2 as 1 ampere here, and distance between the wires as 1 meter. Current as 1 ampere and distance as 1 meter. And let's say the length of the wire is 1 meter. So if we make everything as unit, let's see what we'll be left with. The force per unit length will come out to be small f. Basically, when I say small f, length is assumed within that. Now this will be mu naught is 4 pi into 10 to the power minus 7 into 1 divided by, this is 2 pi into 1. So this becomes 2. So force comes out to be 2 into 10 to the power minus 7 Newton. So when it says define 1 ampere in this case, this means you have to define this 1 ampere. When will this 1 ampere be possible? When a force of 2 into 10 to the power minus 7 Newton will be existing. So 1 ampere is the current when flowing through two long conductors separated by 1 meter, gives 2 into 10 to the power minus 7 Newton of force and can attract or repel the wires, repel each other. Okay. So this once came in the board exams long time back. Recently, this question has not come. But once it has come. Okay. So do one thing, just write this, then we'll come on to the calculation part.
Ma'am, how we know that distance is 1 meter?
No, we are assuming this is a constraint that we are putting. Whenever you have to find out anything unit, then you make all the quantities that can be variable in any of the case as unit. Okay, and then you check, is there any constant left? Like if this was also coming 1, then our answer would have been 1 Newton. But right now, because of this constant, we are getting 2 into 10 to the power minus 7. So this is a constraint that we are putting from our side. That, okay, for current, if we are taking current as 1, let all the variables that are possible, they'll be 1. Okay?
Yes.
Done? Should I scroll?
Last. Done.
Have all of you completed?
Yes, ma'am.
Okay. See, let's practice 2 questions from this. The first one is a very easy question. This says force per unit length. This has already mentioned, you have to calculate F by L, that is small f. On second due to first. So F21, we have to calculate small f. Small f21. So this is equal to mu naught I1, I2 divided by 2 into pi into d. Mu naught is 4 pi into 10 to the power minus 7. First current, this is 2 ampere into what's the second current? 10 ampere divided by 2 pi into d. D means the separation between the wires, which is 2 meter. This 2 gets cancelled. This is 2. This becomes 2 into 10 to the power minus 6. Now, its direction. We are calculating the second one. So your focus should be on the second one. Now, both of them are in the same direction. So they'll attract or repel. The wires will attract or repel? Attract. So if they'll attract, yes, they'll attract. So both of them will move towards each other like this. So where is the second wire going? Because your right now focus is on the second wire. So this is moving towards the left. So you write it like this. You write minus I cap Newton. All are fine here. You can write towards left also. That is fine. Force on 1 due to second, you don't need to calculate. See, magnitude wise, it will be the same. 2 into 10 to the power minus 6. Direction will be opposite. I cap Newton. And I already told you it is just negative. So if it is minus here, it will automatically be positive. So this was a formula-based question. Now we'll discuss a question that came in the board exam. This is a board exams question. First, write down this. This is, I think, in your solved examples of NCERT. Write it. Done.
Yes.
All right. So if completed, I hope everybody has completed. Let's move to the second question. See, here you have a rectangular coil, but no worries about this coil. The solving part of this question is very easy. It's just that you have to identify one thing. This is the first wire, which is having the current I flowing through it. Okay, and here we have the entire coil. Now see, solving the entire coil in one go is difficult. So what we'll do, we'll break it. We'll break it into 4 figures that are known to us. So magnetic field is going inside. Now look, this is the first one. This is the second one. This is the third one. This is the fourth one. So 4 straight wires, we'll solve them. Now for the first one, this is the wire. Okay, and I told you, you'll only consider the same length. Even if it is longer, you will consider it to up to the same length. The different length is not there in your syllabus, so you don't have to focus on that. In the board exams also, it is not expected from you to write the different lengths, because that formula is different, that derivation is different. So you focus on the same length. Before anything, let's let's see where is the force coming. Then only you find out the net resultant values and all you put. First, let us see what is the direction of the force. So in the first one, the current is flowing upwards. Yes. So if the current is flowing upwards, this is the right hand. I'm putting my hand in the direction of current. Now it says magnetic field is where? Inside. So when I curl the magnetic field, means that when I curl my fingers towards the magnetic field, thumb is pointing towards the left. So this is the direction of the first force. Where was the current flowing? Current was flowing upwards, magnetic field inside. So thumb is pointing towards the left. Now tell me direction for the second one. Use your right hand because without that, here it won't be solved. This was even easier because both of them were getting attracted. So this had to be in this direction. But for the above one, you have to apply the rule. Yes, all of you answer. What is the direction of the force? Yes, Safrina, correct. Very good. Anybody else? Yes, upwards, correct. Aisha, upwards, yes, upwards. See, current is flowing towards the right. So we turn our palm towards the right. Magnetic field is going inwards. Thumb will be pointing upwards. So this will be F. Now for F3, what will be the direction? See, F3, you can even solve it. See, this is going upwards, this is going downwards. So they'll repel each other. So if both of them will repel each other, this wire will move outwards. Outwards means away from it, that is towards the right. So this F3 will be the direction of it. Yes, towards the right. Correct, Aisha. Very good. Now tell me all of you the direction for the fourth one. Especially Marwa and Ali. Yes, Aisha, correct. Ali and Marwa, your answer. Correct. Safrina, right? Ali, right? Ubaidullah, correct. Marwa, are you there in the class? You never respond. Please open the cameras, those who have shut their cameras. Yes, downwards. See, current is flowing towards the left. Magnetic field is inwards. Thumb is pointing toward downwards. So this is F4. So one thing is quite clear. This force and this force, they'll cancel each other, F2 and F4. They'll cancel or not? They will. Exactly in opposite sides, their magnitudes will also be the same. But tell me one thing, class. Will 1 and 3, F1 and 3, will they cancel each other or not? 1 and 3, F1 and F3. Because they are also exactly in the opposite direction. They will cancel each other. Will F1 and F3 will cancel each other or not? Yes, no, what do you think?
I think they will cancel.
They will cancel. Reason?
Opposite.
They're opposite forces. See, when do we cancel two forces? Cancelling of two forces means net force is 0. Yes, class? That's what is meant by cancellation of the two forces. That's why they'll cancel each other, Aisha. You're saying this.
No, I don't think.
Current is perpendicular, so that doesn't affect. Okay. Current is perpendicular, that's a different thing. Current is perpendicular in 2 and 3. In first and third one, current is parallel to this I2. Okay, see, I'll tell you, they'll not cancel each other. The reason is that when you say, as I was discussing with you, using the parallelogram, two vectors are there, vectors are in opposite direction. So when if I say a force of 50 Newton is acting here and a force of 50 Newton is acting here, they'll cancel each other because their magnitudes are same. But if I say 50 Newton is acting here and 20 Newton is acting here. So do you say that they will cancel each other because they are in the opposite direction? Or you say 30 Newton is acting towards the 50 Newton because that's the greater force? Second one and first one, both are two different cases. Now look here. 2 pi d that we write. This d is what? Separation between both the wires. In the first one, the separation is small d. In this large one, in this third one, the separation is what? D plus L. D plus L. Denominators are different. Magnitudes are different. So they'll not cancel each other. This is this case. This is not this case. When you like why F2 and F4 were canceling each other because it was this case. equal forces in opposite side, they'll definitely cancel. 50 minus 50 is 0. Net force 0. No direction needed. But if I say 50 Newton is acting, you think yourself in this way, a block is there. You are applying a force of 50 Newton. Other person is applying a force of 30 Newton. So that person won't be able to move that block. You will be able to move because you are applying a 50 Newton in the opposite side. So this is the same case. Now got it? They won't cancel each other. You will get a resultant.
Yes.
So let's find out the magnitude. F2 and F4 aren't needed. F1 and F3 are needed. Okay. See what will be F1. F1 will be mu naught. Now pay attention here. Mu naught, first current here. This is I2. Second current. What is the current flowing? Current will be the same throughout the coil. I1. Now length. I told you take the length same. What's the possible? I cannot take this big length. You have to take the shorter length, then only the length will be the same. So it is already given that this is B. If this is the breadth, so this will also be the breadth. So mu naught I2 I1 into B divided by 2 pi D for the first one, which is directed towards minus I cap. While when I write F2, F2 will be mu naught, same thing, I1, I2B, but divided by 2 pi. The complete length is D plus L in the opposite direction, I cap. So two forces still acting in the opposite direction, but with different magnitudes. Here the denominator will be more, so this will be a lesser force. Here the denominator is greater. So no, here the denominator is lesser. So here will be the force's magnitude will come greater. But anyways, you solve it vectorically, your answer will be the same. Okay, so the net, now you just have to calculate the net force over here. So the net force will be, see, two forces, one is acting on the right side, one is acting on the left side. So this is the greater one, DL, this is